Good morning. Great to be here in Chennai at the SREday. I'm Hemant Kamatgi, work for Ford Motor Company. I lead the e-commerce division of Ford. I have about 30 plus industry related experience and about 20 plus in the field of retail. I've worked in companies, as you can see, retail companies like Target, JCPenney, Reliance Retail, and now with Ford. In all these companies, in the GCCs when they were set up, I was present during its inception. So I've seen all these companies grow to where they are today. Outside of work, I'm a triathlete, done a few Ironman events. The one that you see the picture over here was from a race that I'd done in Busselton last year. So that's about me. The main theme that I'm going to talk about is how SRE has evolved. I've seen it from 2010. And I'm seeing it how it is today, how it has matured. So I'll talk about the evolution of SRE and double down a bit on observability, the main pillar of SRE. So if you look at it back in 2010, when I was involved in a large e-commerce implementation, it was a monolithic COTS product that we had used to build the e-commerce platform. After we went live, the organization was structured amongst two teams. There was the development team, then there was the support team. So development team was organized in the form of a project, right? There were the aim was to make generalists in the organization. And in the support world, we had basically non-engineers. And all their job was to look at the glass and monitor it. And if there was any alert that gets fired, they would open a bridge, get the folks in, development folks in for resolution. This is how it worked then. By 2012, 2013, I saw quite a lot of US retail companies in the e-commerce space making a shift from the COTS product to build a cloud native application. So as the architecture of cloud native application evolved, so did the entire organization structure. So companies moved from a project model to a product model. Soon, right, we had, instead of one big project team, we had 20 to 25 Scrum teams or engineering teams. And each engineering team was self-sufficient. It had engineers, it had QA folks, and very importantly, the folks who were just monitoring the glass, some of them were brought into each of these Scrum teams. This is what was then called as the embedded model, much better than the support model. Now, these engineers, SRE folks who were a part of the individual Scrum teams, had insight into what was happening completely in the Scrum, unlike the support days where they were oblivious to the development work that was happening. So these folks would participate in the stand-up meetings. They would know exactly what features are being worked upon in a given sprint, what is the status of some of the test defects, right? In a way, they acted as gatekeepers. So before, this was not just monitoring the glass, they knew what was happening. So it worked well, but at the same time, they were also reporting to the same engineering manager. It worked well for 2 to 3 years. Then there were some issues that we actually saw. These guys didn't have the teeth to stop a deployable, since they were working under the guidance of an engineering manager who was under pressure from a product manager to ship features faster. So there were times when they were getting streamrolled, right? And things were getting deployed. So their role was a tad diluted. They were stretched thin. After the stand-up meeting was done, they knew the status of the engineers, various artifacts. Once the deployment happened, they didn't know what to do. The concept of reducing toil didn't exist then. At the same time, we had many Scrum teams, very fine Scrum teams as well, right? With 5 to 6 team members, each having a couple of SRE engineers. What this meant was there was less collaboration between the SRE engineers of the various Scrum teams. Lack of standard tooling. Since each of them reported to a different engineering manager, they had to take directions from their bosses to implement tooling what befitted them then. So there was a lack of collaboration, lack of standard tooling, as well as the incident manager process was also not standardized. It was different in different Scrum teams. 3 years back when I joined Ford, we were in a similar situation. It was not a support model, we were in the embedded SRE model. right? So we had multiple SRE folks embedded in different Scrum teams. So looking at these gaps, we went to the next model, what we call as the central model. So in the central model, there is a separate manager, right? Leader responsible for SRE, and his sole job is to make the application reliable in production, right? So this is the first time we saw a tussle between the engineering manager and the SRE leads, because SRE wanted reliable application, engineers wanted to ship code faster to production. But with this, what happened was they got clear direction from the one manager, right? So tooling became standardized, the incident management process became standardized, and of course, right, with the new SRE mantra, these guys were also focused during 50% of the time goes in incident management. I get it. But for the remaining 50%, they worked on reducing toil, writing scripts, right? So this was much better than the embedded model. So they had a role to play here, plus they were not stretched thin like in the embedded model. So this works very well, and this is how it is implemented in my organization. Okay, and then what next is the problem? So within a business area, you have multiple business units. Each business unit's maturity in terms of SRE is different. It's not the same. And I take pride in saying in my area, we have matured to a great extent, better than some of the other business units. So now how do we scale this across? Remember, as I told, 50% of the time is spent in incident management. So that is pure operational cost. From a leadership perspective, the goal is to reduce the OpEx cost. And if you were to replicate the SRE team across different business units in a given business area, so you are adding more labor, more people, more tooling. So all of this gets replicated amongst as many BUs that you have. So the whole idea is to reduce the business unit. So the problem that I'm trying to solve now is how do you scale the central SRE model across all the business units? This is still work in progress. This is not yet solved. But the way I'm approaching that is have a core SRE team, which is responsible for the entire tooling and infrastructure, right? Defining the SLOs, creating the error budgets, right? Define monitoring, alerts, all observability, all of that will be done by the central team. And in each of the business units, you plug in, like a spoke model, right? Hub and spoke model. The central SRE is the hub, while few engineers are embedded in each of the Scrum, each of the business units. So in the case of an incident, the bridge will be opened by the central SRE team, but the resolution will come from the individual teams. So that is the only way we can scale the central SRE model across a larger business area, right? So this is the state where we are in. I've seen it all, from a support model to an embedded model to a central SRE model, and I've coined a new name for this, the scaled central model, right? Okay, now I want to talk a little bit more on observability-driven development. So if you look at our architecture, it's a distributed architecture, right? Front end is all built on micro front ends deployed on different various Node.js servers. Backend is all microservices, polyglot persistent, looks great. So development is good, the developers enjoy it. But the folks who don't like it are the SRE folks. Because when there is an error, identifying the problem where it lies is not easy. In the monolithic world, it was pretty easy, right? You just download the source code, put some breakpoints in the given functionality, run debugger in your IDE. You know where the issue is, you fix it, and you deploy it. You can't do it here because all the calls are happening over the wire. They are not in-memory calls. So that means observability becomes very important, especially in a customer-facing applications like ours. We have something called as MTTR, mean time to recover, and the goal that has been set is only 60 minutes. So if I have to recover from a critical incident in 60 minutes, okay, of the 60 minutes, 10 minutes goes for CI, CD, and all of that. You're left with 50 minutes. In that 50 minutes, the time to detect and acknowledge has to be about 5 minutes or lesser than that. In this way, you can give 30 to 40 minutes for the development team to fix it, right? So to acknowledge and detect, if we are given just 5 minutes, observability becomes extremely important. So it is no longer an afterthought. Observability is not just the job of the SRE team. We have to shift it left, and it has to be baked into our implementation process. So while a developer is developing, he should instrument all the 3 pillars of observability at the time of development itself, be it logging, tracing, or metrics collection. Right? For logging, we do have all the standards, right? Native to that application, there are logging available. There are logging agents on the cloud which can route them to a centralized telemetry server. Ditto for tracing. It becomes very important to have a proper tracing framework built in, so that for a critical functionality, if you want to trace from front end till the backend data store, you can do it. So we centralize all those telemetry data and visualize it, which helps in the SRE folks in fixing the issue, identifying the issue faster, so that the fix is equally faster. So ODD has to be built into your development cycle. What works very well along with ODD is progressive delivery integration. They work in tandem. So whenever there is a deployment, we never go with a big bang approach, right? So if something goes wrong, you end up in rolling back the entire deployable and fix it and redeploy it, right? That is a sort of loss of phase, especially when you are doing a customer-facing application. To fix that, there are multiple approaches. A canary deployment we have. You can choose A/B testing, feature flags. All of these are well known, but that has to be implemented along with ODD. So whenever a new feature gets deployed, you subject that new code to just 5 to 10% of the traffic, right? Run all your observability tooling around that, right? Check the logs. They should smoothly roll over. There shouldn't be large exceptions, track traces. The matrices, the latency, error rates, everything should be under check. If this works well, you scale it to the entire organization. So ODD and progressive delivery integration is a must. And in conclusion, I would like to say, embrace ODD in your organization, right? So it helps you towards the end. As I've written here, ODD is different from a TDD, right? When we started TDD a decade back, we shifted left the entire testing process. So against a given specification or a requirement document, all the test cases were written. Against those test cases, code was written, right? So we had lesser defects. But ODD helps you in managing the chaotic and the wild production environment. On a lighter note here, I would like to quote one of the stories, right? Recently, sometime in June, as I told in my biodata earlier that I'm an open water swimmer, I, along with 3 of my friends, we had gone to swim across the English Channel. This was in June of 9th, right? So we had to swim from Dover in UK till Calais in France. So for months before that event, we all trained in a swimming pool in a controlled environment for months together, right? Developed endurance. All of that was fine. But when we went to swim, that was like a TDD, right? A test, doing it against a given specification. And when we went to swim in the Atlantic, it was a wild, completely different experience. We were thrown across like toys by the waves, very difficult environment. That's ODD, right? Of course, our attempt to cross the channel ended in a debacle, but that's a story for another day. I will leave to tell you. But yeah, so in conclusion, observability should be used early in the software delivery lifecycle. Moving on, how to balance innovation and reliability. Okay, back in 2013, when I was working in Target, we tried to implement, or rather we implemented social commerce in partnership with Facebook. So the development team was combined, Target and Facebook put together. So there we learned something new. So whenever the sprint started, every developer was getting about 10 karma points, right? So then he's assigned a story, he writes the code against the story, deploys it. If something goes wrong, the SRE manager would deduct a few karma points out of him. So the next time he writes a story and tries to deploy, if the karma points are less, he would stop the deployment. He would ask him to test more, right? Show all the corner cases. So as and how, right? If you are more reliable, if you have more karma points, the deployment is better. If you have less karma points, you are held back. This was back in 2013. Fast forward to 2025, we talk about error budget, right? What we do as a SRET in 4.com is we clearly define the service level objectives for all our APIs. That clearly promises what our reliability is. Against those SLOs, we measure the SLIs, right? The actual matrices, right? For performance of our APIs. And the difference is what you call as error budget. So starting off the sprint, all of them get a certain error budget depending on the SLO that has been defined. Recently, we had a deployment which consumed about 70% of the error rate. So what the SRE manager did was he told the team, no more deployments, right? You can deploy for reliability, but no more feature development. So then the product got involved, right? In this setup, in this new SRE model, SRE is not just the responsibility of the SRE team or observability. It is a joint, right? Everybody's responsibility, from product managers to engineering managers to the SRE folks put together. This also helped us build a culture where finger pointing was eliminated. Now everything was based on data. Discussions were based on data-driven. They were not based on gut feel or a particular manager took the decision, right? They were all data-driven decisions that we took. And more importantly, reliability costs were a shared responsibility, not just SRE. The product too was involved. So when they get to know a particular deployment was full of defects, they realized at no point in subjecting that code to extra customer traffic, but get that fixed, right? Net error budgets, reliability becomes a feature and not a cost center. Moving on to monitoring. So the 4 golden signals of SRE, they've been around for long, and most of the API developers are aware of it. Latency, traffic, errors, and saturation. But customer-facing application, we monitor 2 other things. One is called as RUM, real user monitoring. The other one is synthetic monitoring. In real user monitoring, APIs, we get it, right? How they are behaving. But in RUM, you get to know exactly the experience that the customer is undergoing, right? In a way, it is reactive in nature because you see it cannot predict anything. So to fix that issue, we use synthetic monitoring, where we create bots and we define how they are run against with different customer segments, different regions put together, right? They can predict if an issue is going to happen, right? So typically, organizations use especially with customer-facing applications, use RUM and synthetic monitoring together. One helps to get the actual experience, other helps in predicting an impending issue that is going to happen. So observability is not limited just to the development environment. It is also used in CI/CD pipelines, right? Be it logging, tracing, or mattress collection. All of them, what were applicable for development, are now applicable for a pipeline as well. So if you look at it in a CI/CD pipeline, you would like to know the build time, right? If a build is taking more time, there is an issue that needs to be fixed, right? So without this metrics, you will never know. So typically, we capture all these metrics as a part of the pipeline. Test pass rate, right? This shows how stable is the code, right? Amongst all the test cases that were written, when we ran it after the build was done, how many passed? Failure rate, how many times the build failed, right? This is if you are familiar with the DORA matrices, we talk about change failure rate. How many times we deployed to production and what issues we faced. This is something similar, right? How many times a pipeline failed. And mean time to recovery, right? How quickly we were able to recover from the build failure or the pipeline failure. You can also look at matrices related to resource usage. So all of these CI pipelines are run in typically a cluster. We use a Tecton. And if the resource utilization is high, whether it is memory or CPU, you get alerted. So with that, you also know what to fix, right? How to scale your CI pipeline horizontally. Security scan results. So as a part of the pipeline, most companies, we run the static code analysis. You get to know how secure the code is. Only the secure code gets deployed to production. So all these metrics collection, if we talked about latency, error rate, traffic, and so on and so forth, for a deployable artifact is applicable for a CI/CD pipeline as well. Logs, whatever the pipeline logs, right? Route it, forward it to a central server. You can check what the issues are being seen in the logs. Tracing, you can trace a build across various environment that goes on. So it is similar, but we have to embrace observability in DevOps as well, which will help us to have a good pipeline environment. So we talked about observability in development, observability in pipeline, now observability in FinOps, right? So we achieve a great agility in when we build a cloud native application, right? You can deploy faster. But at the same time, we have to keep an eye on the cloud cost the application incurs. So typically what we do is, on a monthly cadence, we meet up with every Scrum team. We look at the services they use, the cost they incur, and if there is any scope for optimizing that cost. So we look at resource utilization. This might resonate to many of you guys. Typically, some of your non-prod environments are not used effectively, right? So you get to know as a part of this review, a sandbox environment, it exists, but nobody uses it. So this is an opportunity to clean that up. Some resources are lying idle. If you have a chance to clean up, you can do that as well. Unattached disks, right? So there are resource optimization, and then there are usage optimizations as well. Instance scaling. There are cases where your infra is scaled much more than what the application requires. So you change that so that the cloud costs come lower. Storage, right? Logs, if they must be sized properly, they must be rotated properly. In the absence of that, we know there is an issue. Okay, Mark has come here. That means my time is over. I will end here. So observability in FinOps and in development is equally important. The next thing is observability in AI. With that, I will end my note here, and thanks for listening, and have a great rest of the day. Thank you.